Welcome to my channel, everyone. I'm Topdawg Shadic, and joining me is Rebecca. Her channel is called Bread of Life, link in the description. So how are you today?
Great. How are you, Topdawg?
Pretty good.
Thanks for having me on your channel.
Yep. So did you want to tell us a little bit about yourself?
Sure. Well, I am a Christian evangelist, and so I love to tell people about Jesus. That's the main thing I do. And I started a YouTube channel back in 2018 just to share the good news about Jesus in different ways. And now it's kind of morphed into, interviews with people and different topics. So I have a really good time doing that. And I would love to have any of you on my channel. I mean, I'd love to see you show up, watch live streams, chat. And I just started a new thing called Atheist of the Month. And I give away a $50 Amazon gift card to the Atheist of the Month on my channel. So, and there's a nice certificate here. So come and participate. I'd love to have you.
Okay, sounds cool. And today's topic is, what is science? So, what is science to you?
Well, science is the study of the world. Through observation, experiment, we discover truth about the world.
Okay, cool. And what I think is science it's a tool that best helps anybody understand the world and the universe as it is and how it works.
Okay. Why do you add best in there?
The best tool for understanding the universe and the world, whatever. It's
Do you think they're
because it's the best one to looks at real life and examines through multiple people too to do it of a single subject or group of subjects maybe.
okay? Do you think there are other tools for discovering truth about the world, or is science the only one?
There's probably other ones. It's just science is the best one since it collaborates with other people about the same thing. So to see it from other perspective, so we get a more accurate understanding of what is going on. Better, I mean, it's a likelihood.
Okay.
It helps us have a better likelihood. It's not perfect or anything. It's just the best one to give us the best likelihood of what is out there or how it works and what is what. I have a video that maybe somebody else's question of what is science too. Did you want to see that?
Sure.
So I have a form. If anybody ever wants to check out for themselves, it's scienceandnaturalism.com. Let's see, scienceandnaturalism.com. Okay. And then this will pop up here. And on the second topic on the first homepage will be my ultimate guide to understanding science. Click that. And then go down to any subject you want. But for today, we're going down to what is science? Let's see. There it is. and I have 2 videos. I showed Rebecca a few days ago the first one, but today we're going to watch the second one. I mean, I showed her in private. So, yeah. Okay. We're going to watch the second one. First time. Okay.
Our home planet Earth has more events occurring on it than we can imagine. These events involve the living organisms, inanimate structures, things which we can see, those which we can't, events that amaze us, and those which terrify us. The very formation of our Earth was another massive event. These events bring with it a large number of questions that arise out of curiosity to explain or understand the world we live in, the world around us. If you have ever wondered what's going on, how these events take place, or why is it so, well then, you are not alone. These questions run in the minds of billions of people every second, every day. The answer to all these questions is simple and lies in one word: science. Now, probably your next question is, what exactly is science? So let's understand. Science
Oh, yeah. If you want me to pause, just tell me to
Okay.
get a clear understanding of what just was said or shown.
is an answer. It is the knowledge that we get when we ask questions. So, if this is you, why do all your belongings or anything that you throw up in the air fall to the ground? The answer or science behind it is no big deal. It's gravity. You see, the earth has an attraction to all the objects known as gravity. And this invisible attraction is what keeps us on earth and not float away in the air. The funny thing is that gravity was always there since the beginning, but it was only understood and explained until not a very long ago by a very inquisitive person who happened to ask a lot of questions. He was very convinced that an apple doesn't fall far from the tree, and that's because it fell on his head. Yes, that person was Sir Isaac Newton. So gravity existed even before the apple fell on Newton's head. But it was understood and explained only when Newton decided to ask three fundamental.
Well, I think there was a myth actually that Newton got hit in the head by an apple, something like that. I heard it was a myth that it was just something that fell next to him or something, and then it came to his attention. Okay.
Questions: what, how, and why. So you see, science involves you. Well, not just you, me, and everything around us. But we only understand it when we follow our curiosity and ask questions, a lot of questions, and try to find answers to them. But many a times, one question can have more than one answer. So there is often more than one theory to explain the science behind each event. It's a lot like a maze. At the center is the event occurring and the questions related to it. And the various paths to the center are the answers to it. Based on our understanding of all the events in the universe, we can classify science into three main branches: physics, chemistry, and biology. Let us look at what these branches are and how they work in the making of something as simple as a lime juice when you're thirsty, and understand where these branches come into play. This is where physics gets into character. Physics is concerned with the force with which one holds the spoon and the motion involved while stirring the juice fast or slow. It is the branch of science that deals with all the types of matter in and beyond the universe, their nature, their properties, and all causes and effects of manipulating them. Then comes the part where all the ingredients start getting mixed in order to give us lime juice. This is called chemistry. It deals with the reaction between two or more types of matter to form a new type of matter. For example, when the atoms of hydrogen and oxygen are mixed together in an appropriate ratio, we get a molecule of H2O, which is also called water. Interesting, isn't it? And finally, there is biology. Biology is concerned with how your body can extract the benefits from the juice. On a broader scale, it is concerned with all the living matter in the universe like plants, animals, and microorganisms, their life processes, and their relationship not only with one another but also with the environment in which they exist. Now, if you have been observant, you would have realized that all these branches, though differently listed, work together in making lime juice. This togetherness of these branches is not only in the case of simply preparing a lime juice, but also in case of every event that we see, perform, or experience in our lives. Yes, they are like friends who work in harmony. Now, whether it is physics, chemistry, or biology, everything falls under the two main categories of science. The first category is based on asking questions. This is termed as basic science, where you find crazy scientists experimenting in the laboratory like in the movies. The only thing is, they're not really crazy. Basic science always follows a cycle. Let's see what basic science is using the same example of a lime juice. The first step in the cycle involves asking questions about the origin of lime juice. For example, what are the ingredients used to make lime juice? What can be used to dissolve these ingredients? And how much of those ingredients can be beneficial? Could the lime juice do well to the body if consumed? The next step involves making an assumption or a hypothesis about the origin of lime juice. For example, we could use the juice of lemons to make lime juice. The lime juice may taste a lot better if we use sugar and salt. It could be that half a glass of water could be sufficient to dissolve all the ingredients. After we have made such assumptions, they need to be verified by experimenting. That is, we must try making the lime juice based on our assumptions and test to see what we assumed or predicted is true or rather false. After performing these experiments successfully, a conclusion has to be made where verified facts are established. That is, in this case, one can say that the lime juice is made only of juice extracted from lemons. It does indeed taste good with sugar and salt. That half a glass of water is sufficient to dissolve all the ingredients, and that drinking lime juice does good to the body. So you see, basic science always follows this cycle. Now, let's move to the second category of science that involves determining the various utilities of the now prepared lime juice. The answers might be making fruit juice concentrates, curing indigestion, reducing blemishes on skin. Therefore, this category of science is called the applied science, as it simply looks at the various uses of what is already established. Simply put, basic science is concerned with knowing something, and applied science is using what you know. We can say applied science depends on the basic science. Well, so far we have seen that science can be all fun and games. So it's about time we ask the most important question of all. Is science always this good? Or does it also have a not so good side to it? To understand that, let us look into some examples. Let's take nuclear energy for instance. It can be used to make nuclear power, which can act as a substitute for electricity and which can be much cheaper for us. Or it can be made to make nuclear bombs, which can have devastating effects. Another example that comes to my mind is the cell phone. Yes, it is true that the advent of portable phone, also called the cell phone, has made our lives a lot easier by allowing people over long distances to not only communicate faster but also more effectively. But do the benefits really outweigh all the risks that cell phones are likely to cause to our body, like the high probability of brain tumors? The question here is not about science being good or bad, because now we know science is knowledge, and knowledge is never bad per se. The real question we must ask ourselves should be, are we using science for something good or something that will cause harm? We can say science has the power to both destroy and heal.
To be clear, that cell phones don't have ionizing and radiation that cause damage to the DNA or anything that causes brain tumors or anything. It, that was just a joke, probably, or something. And it's like the closest thing would be microwaves. And that is only just vibrate the water molecules, and it's only a certain part of the spectrum of microwaves that do that too. It's not like all microwaves are dangerous to that extent. Like that's why we have 5G and stuff now. That it's not affecting people like melting or making their body warm up to that. I mean, so it's confusing how to what people understand about what radiation is not. Because visual light is actually radiation, so it's not like everything that's radiation. Yeah, radiation or electromagnetic spectrum is it's just, you got to look that up and stuff for yourself if you want to know more. This is just about what is science we're trying to get through. Sorry the video was so long too. I
no
forgot how
problem.
long. I didn't look at it. It's almost over though, so here we go.
Okay.
But it only depends on how you view it, and more importantly, how you use it. We do have a choice. If science is pursued with a generous and a compassionate heart, it can really change our world in more ways than one. The true potential of science is beyond our imagination. But then we can always start by letting the scientist in us ask the three fundamental questions: what, how, and why. Hope you found this session.
Oops. Okay. Over.
Okay.
So,
What did you want me to
what did we
understand from
learn?
that video?
Science is about observation and testing and stuff, I guess. So experiments and stuff that we could, and then we observe and stuff from those experiments, and we can then write that down, and then share to others that what we learned from doing those experiments and observations. And anybody can do it, kind of like. So it's not like forbidden or anything. Science is not. I mean, there's some things that are hard to do for a normal person, but you can always look it up what they did, and maybe they had videos of actually showing how they did it and stuff. So get more than one perspective than just talking or from drawings or anything. You get to see the actual experiment being done.
Mm-hmm.
So you know that it's a real thing.
Oh, absolutely. And I think that's the definition I gave you at the beginning, right? About observation and experiment. So, is there something about, is there anything I've said that would make you think I think science is forbidden, since you used that word?
I mean, it's like for people to find out about anything in science. I mean, it's some people have like the idea. Not I was just not saying that you said anything about it. I'm just saying that people have that have a hard time understanding what science is and stuff. Not just you. I'm just saying for the audience maybe too. So.
But what about what I have said makes you think that it's hard for me to understand what science is?
Well, in other videos from other people that you were interviewed by, you kept saying that evolution isn't a part of science. Or is that right?
Well, it's definitely part of what scientists are attempting to find evidence for, but I don't believe that there is good scientific evidence for evolution. So it's definitely widely believed among scientists.
It's like one of the most studied one, and it's the most confirmed. The one that has been verified, that shows all the levels of the theory, which is a theory is actually a group of facts, and it tells us it makes us help us understand what the processes and stuff. So a theory is like one of the highest things in science held. So that helps us explain certain phenomenon and stuff in the universe.
Right.
It's not theories.
What is the evidence?
It's a scientific theory is different. Sorry, scientific theory is. Oh.
Go ahead.
Sorry. Yeah. I mean, there's a difference between theory as a colloquial meaning, as like a guess or something, and like a scientific theory. I mean, it's a like what I just said earlier, a collection of facts.
What do you think are the facts about evolution?
Well, that let's see.
What are the verified
facts? See. I was ready only to talk about what is science, but
okay, that's fine.
I guess we can go into.
No, it's okay. I don't want to put you on the spot. That's fine. I won't put you on the spot. We can talk about that another time. But this is what I want to say about that. I'm not disputing science, like actual observations and experiments that we have, repeated and verified. I'm not disputing that. What I am disputing is that the evidence points toward evolution. I don't think it does. I think it's actually goes the opposite direction, that there's enough scientific, that we've done enough scientific experiments and observation that we can recognize that evolution, and when I guess the word evolution is a little bit tricky, because if you just mean evolution as change to organisms, then absolutely we see change to organisms. But what we don't see is new structures being built in organisms. We don't see one type of organism changing to another type. We don't see new information being introduced to the genome. And so this is a problem for evolution, Darwinian evolution. So we definitely see changes within organisms. We see mutation and things like that. But the question is are those changes that we see enough to produce what this concept of evolution has proposed? And I don't think we have scientific observations that confirm that.
Well, do you agree that the longer that scientists observe and test something, the more accurate they will get? or to explain it? We'll be explaining it.
Well, that depends. It depends if the hypothesis they're starting with is a good hypothesis or not. So I think, scientists can continue to make observations. What they're going to conclude is, that's something I can't predict, right?
Let's see. I guess for some people, science is like speaking another language. Do you think?
Well, I mean, of course, there's
So,
lots of jargon within science that a layperson is not going to understand. If it's not your particular field, you won't understand everything that's written in scientific journals.
yeah. So not scientist doesn't mean that they know everything. Scientist is just a person that studies the real world and universe and stuff. So and they have different niches, whatever that they go into, but they can learn like anybody else. Learn other things that's not what they're studying. I mean, in the real world, they can actually study like what other people have done. That's what we're trying to actually do. I mean, that's all we can. I mean, we can actually do real science too. If we can actually make our own versions of science, or not versions, but we could do science. What do you call it? Fields that we can actually invent our own. If it's something that in the real world that no one has ever thought of and stuff, we can probably invent our own. What do you call it? Not invent, but discover. That is.
Mm-hmm.
But we could call it like new name if we want to, maybe if it's something that's new. But if it's something that we already know and stuff, so that it's confusing. It's you have to actually look it up and stuff, what you're looking at for, and it's just a thing I thought of earlier in the day. Okay. Then it's better to learn how to think than what to think too. And let's see. They have.
So do you think with regard to evolution that you've been taught how to think rather than what to think?
Yeah. That's what science does. It shows us ways of what the real life shows us. So I mean, we can look at our own self and stuff. So that's how we know a little bit. If we look at anything, we could look it up on the internet. People that have actually looked even deeper and stuff. So we have a reference in real life of our own, and then we can have a little bit better understanding from somebody that actually took the time to study deeper. And okay, I think that's done of my list of things I wrote. And now I guess I'll go to the next thing, since we're talking about the hypothesis and facts and theories. And then I have another video that helps, the best one that I could think of that helps explain the difference between facts, theories, and law, or hypothesis versus law.
Yeah, before you start that, can I say a couple things about that video?
Yeah.
The one that you showed? Okay, so, it kind of showed like everybody in the world is asking all these questions, billions of questions. And, it said like, there's one answer. The answers that they're looking for can be summed up in one word: science.
No, they said multiple answers. Oh, that's what you're talking about.
Well,
there was
what
multiple
I'm saying
answers
is
for the same subject, or that we're looking for.
Well, the point that he was trying to make is that, science answers all the questions that are in our minds, right? And I don't think that's true at all. There's lots of questions that science doesn't answer.
Yeah.
Science does answer a lot of questions.
Yeah.
But, there are questions that science doesn't answer. So science doesn't answer about what your purpose is. Science doesn't answer who God is, right? That's something you have to discover in other ways.
Actually, the purpose, I mean, there is purpose to life. I mean, science can't answer that.
What
for
would be a
life, but it's
scientific
not answering how.
experiment? What would be a scientific experiment that would show you what the purpose of life is?
Observe a life form. It's to ensure the next generation survives, kind of. It's reproducing and stuff to make the next generation to keep surviving, you know. That's one of the answers that we find out from observing, you know. I mean, that's not our mental answer, though. That's a different kind of thing. That's more psychology, though, isn't it? Psychology is different a little bit than understanding natural phenomenon.
Right. So my point is that science doesn't give you the answers to everything about life. And this is a problem with naturalism, that there's the idea that all that exists is the natural world. And there's kind of a, you know, I think, you know, there's this sort of worship of science that sometimes goes on, and that video kind of illustrates it, you know, that like all the answers can be given by science. And that just, you know, that's not true.
No, that's not what it said. Answers of the natural phenomenon that we can observe. I mean, most of the answers.
Okay.
There are like some things like before the Big Bang and what started the origins of life. Yeah, well, it's kind of answering those. Well, the origins of life is kind of being answered, but the Big Bang is kind of impossible to get farther than the point, like Planck length or whatever of time, because it's not observable, and not even I don't think the math even could show it. Just we could see it only when the point of existence, but not anything before it. So that's why if science was lying, they would give you the answer, though, wouldn't it? So by not answering, that means we're talking about the stuff we do know.
Okay. Well, the other thing this doesn't have a lot to do with our topic, but I just thought it was kind of interesting how he said, you know, hey, now we understand gravity. Like it's a simple thing basically to understand. And actually gravity is still not well understood. You know, we do understand some things about gravity, but gravity is still a mystery. So, you know,
Well, we can have a mathematical thing, E equals mc squared, which explains a lot, actually. And then we have quantum mechanics and stuff that help explain the tiny universe of our understanding. So it's there are being answered because we do know those. Science doesn't say things that it doesn't know, kind of thing. So
okay.
So I have other things on here in my forum too that like misconceptions about evolution and how evolution works,
Mm-hmm.
and animal hybrids. So if animal hybrids, well, they could be different animals, or seemingly look like different animals that seem to be able to breed together and make another animal. Pretty cool.
Mm-hmm.
And then what is intelligence? And then you have there was no first human, and you got PBS Nova episodes that help us see the world in different ways that scientists have shown. I mean, the scientists have done and actually gone to places and researched stuff, and they even have other things that aren't exactly science, but like Hindenburg. I guess there is science in it, but it's confusing. It's like National Geographic doesn't always do science, And then we have Big Bang up higher on, and then so much you have to look it up for yourselves. Anybody that wants to see these forums. So the first one I put in this forum is at the bottom because that's how this format goes, and it helps us understand the difference between fact, theories, hypothesis, and law. But I have also the not just a theory. It's just a web page that shows in words about not just a theory. That I guess it's talking about evolution is not just a theory. It's saying. And it has some sources in there. If anybody wants to see that, you can just go to notjustatheory.com. Simple as that. Okay. So here's the next video. It's called that. Yep. This one helps really get a better understanding.
We need to get something straight. Evolution by natural selection is a theory. So is climate change. But people keep saying that like it's a bad thing.
It's okay to be smart channel. Yep, this is it.
I get it. I understand your frustration. We're all searching for ultimate #truth, and complex, challenging ideas don't always fit nice and neatly in our brains. But what is truth? Are there different levels of truth? Are some truths truthier than others? Well, I don't know, but I do know this. Science is the absolute best tool we have for understanding how the universe works, and theory is not a four-letter word. If we're going to trust science together, the least we can do is speak the same language. Words like fact, theory, hypothesis, and law mean something totally different to a scientist than the way they're used in everyday speech. So let's get them straight. Facts are really just observations about the world around us. And we observe things every day, like that it's bright outside when I look out the window. And we often develop explanations for those observations, like, okay, the sun is probably up. Congrats, we just developed a hypothesis. But a hypothesis isn't something you prove, it's something you test. So let's walk outside. It's bright, the sun is up, hypothesis confirmed. Way to go, we did a science. We often come up with multiple hypotheses to explain an observation. We just eliminate the ones that are wrong. What's left over is not a theory or a law or an ultimate truth. It's just a possible explanation for something, one that can lead us to new hypotheses, which may agree or disagree with the original one. It's a never-ending story, only without the big fluffy dragons.
That's so good.
When enough hypotheses have gotten the old scientific check mark, we can pile these all up and turn them into something greater, a theory. A theory is the way we know something works, based on the evidence we've collected and all the hypotheses that we've successfully put to the test. The best thing about a theory is that we can use it to make predictions, and not just about the way things are, but how they will be. You may have heard someone say something like, I have a theory about why cats purr. I think it's because they're actually tiny robots, and those are their gears. Well, that's not a theory. That's actually a hypothesis. It's something that could be tested, but don't try this at home. This cycle, taking facts and observations, thinking up possible explanations, testing those explanations, and then making predictions based upon them, that's what this whole science thing is about. Being a theory isn't a bad thing. It means that idea got the gold star, the blue ribbon, a big shiny trophy that says, countless experiments have shown that I am sufficient to explain all the observations that I encompass. Now, to see if you got this down, let's look at some examples. Fact, people get sick. I think we can all accept that. Hypothesis, people get sick because something gets in their body and starts doing bad things. Test each hypothesis, throw out the bad ones, and we're left with a framework that lets us understand why we get sick and make predictions. The germ theory of disease. Okay, let's try another. Evolution is a fact. We know that it happens, no doubt. But how does it happen? Evolution by natural selection is a theory. We've come up with thousands and thousands of hypotheses about it, tested them, thrown out the bad ones, and we developed a pretty darn good framework for predicting how living things change over time. So yeah, it's a theory. Stop saying it like a bad thing. Calling it a theory means it's passed the toughest tests that we can throw at it. And evolution has been tested maybe more than any other theory we know of. We should really call it the theory of the fact of evolution. What about something as fundamental?
You understand that? Oh, sorry, you're paused or you're muted.
Yes, I understood that, but he's incorrect. Evolution is not a fact. You don't get
By
to
natural
assert-
selection.
Well, he said evolution is a fact. Evolution by natural selection is a theory, right? But where do we get evolution is a fact? Where does that come from?
From observing real life of animals and creatures. And it can be viruses even. It doesn't have to be just life, I guess, because it's a biological thing, I guess.
Well, again, I mean, he would need to define what exactly he means when he says evolution. If he just means organisms change, then that's a fact. But if he means organisms change from one type of organism to another type, then that is not a fact. That has not been observed.
Who told you that? Who told you that? Was the thing of evolution. We're always our ancestors.
Okay, what about ancestors?
We're still our ancestors.
Where does that idea come
We still
from?
have the DNA from
What
observing.
observations and experiments does that come from?
Observing every DNA. I mean, from all the different life forms and stuff, we could trace it back. From you, like your parents, you like Ancestry.com and what's the other ones?
Right. Well,
123me or something.
me having similar DNA to my parents is quite different than me having similar DNA to a tree.
Well, that's
Right.
pretty far back.
Well,
We have a lot of in common with that. Any trees, we have a lot of DNA that is from our past.
well,
whatever
the
we were.
assumption that there's a connection between me and the tree, that is an assumption. That is not something that is observable or testable.
DNA shows us that it's part of us in the same area, like almost. Well, lots of things have changed over time too, but it's still there though.
Well, again, Topdawg, that's an assumption that there was a connection between us and the tree. There's no experiment that shows that we are connected, that we have a common ancestor with a tree.
It's like saying there's no experiment that can be shown that you had parents, or your parents. I mean, that's not making any sense. You can't relate your parents to be related to your parents, almost like you're trying to say.
Well, no, that I'm related to my parents is testable.
Mm-hmm.
Right?
Same process.
It's not the
I'll
same
just play the video a little bit more.
Topdawg. Okay.
Fundamental is gravity. Is that a theory or is it a law? In science, a law is a detailed description, usually using math, of how something happens, like the movement of gas molecules related to temperature, or how mass and energy are always conserved. But a law doesn't tell us why something happens. Gravity, as it turns out, is a law and a theory. Newton's law of universal gravitation describes precisely how two objects will attract each other based on their masses and the distance between them, and gives us a nice formula we can use to figure it out. Textbook law. But Newton's equation doesn't describe what is happening or why. To do that, we need a theory of gravity. Fact. If I drop this, it'll fall. Law. I can mathematically describe how fast that apple.
He meant if you let go, the dropping only happens because of gravity. So it was a little worded a little different. Understanding the same.
And the Earth will accelerate toward one another based on their masses and distance. But why is it happening? Hypothesis. There's a force pulling on the apple, or maybe there's something about the universe and the way it's structured that makes massive things fall toward one another. Or maybe the apple is like magnetically attracted to Earth or something. Eliminate the bad ones and we're left with a theory. And thanks to Einstein, we've got a theory of gravity called general relativity. But once scientists stumbled upon quantum mechanics, they began to realize that Einstein's relativity didn't account for what was happening on the very smallest gravitational scales in the universe. General relativity is still great at describing the universe at the scale that we interact with it. But even the theory of gravity is incomplete. Does that mean we throw it out because it can't explain everything? No, I mean, if you get a flat tire on your car, do you get a new car? If you change the tire, is your car a different car all of a sudden? All of these fit together to make the scientific machine. We're constantly adding and taking away parts, but it keeps on running just fine. It just means we've got more work to do to make Einstein's theory even more right. Science is never done. It's always changing, and this bothers some people. How can we trust it? How can something be strong and robust if it could be different tomorrow? The goal of science is to devise frameworks that describe how things work, to truly understand why things are the way they are right now, so that we can know how things will be in the future. And if we can learn to trust science in all of its fuzziness and incompleteness, I predict that future is going to be very bright. I like that theory. Stay curious.
Okay, that's it.
Okay. What do you want me to understand from that video, Topdawg?
That we can explain things like evolution, to understand how things work, how life gets its different variety and stuff, how widespread it was, and how things adapt and everything, and just to help understand what science is and all about. The goal of understanding the universe.
Well, I think that's a
predict a
great
little bit,
goal
maybe.
to understand. And, so I love science. I think it's great. It's helped us with a lot of technology. It's helped us with, medicine, giving people
Yep.
good health, surgeries, like science is doing all kinds of things for people. So I greatly appreciate, what we've accomplished through science.
Virus or vaccines and stuff too.
Yep.
We know about those vaccines, know how to make vaccines because we know, or more is that we know what variant to vaccine against, most likely. So we can have a widespread immunity. So it can, make the same thing in the lab for people to be immune better than without. So you could. Hard to word it right.
Yeah, I understand. Yep.
So.
Exactly. Well, I think we're in agreement on that.
How they made the COVID vaccine actually so fast because we had already known about other viruses and stuff, and then we could make the knowing about what type of what do you call it, vaccine, I guess. It's hard to say what goes on in the vaccine and stuff because I forget what they're called. That they're just using the part where they connect and stuff to the cells and stuff to block that. So they're not always just making viruses or dead viruses. I mean, to make a vaccine, but they can make just the endpoints. It's pretty amazing, and know what type of endpoints they could stuff to for the spread to other people from across the world. For that whole year, I guess. Like the flu vaccine keeps on evolving, so they have to keep on doing it every year. Making a different version, I guess. So that's why you have to keep on getting it every year, I think. That's what they say. So we have to know about evolution to understand how to make a vaccine. That's what I'm trying to say.
Well, if you're using the word evolution to just mean change, yes, absolutely. Then we need to understand that viruses change, and they do change. But the coronavirus, it makes changes. It has changes occur, but it's still a coronavirus.
Yeah.
So it's not changing from one type of organism to another type. No one's expecting the coronavirus to grow an eyeball tomorrow because there's nothing
that's complex.
Exactly. And this is what evolution has not provided for us, is a mechanism by which organisms can fundamentally change their structure. And especially with regard to, things like organs, where do you get that? That doesn't, a human organ or an animal organ is an incredibly complex system that has to fit in with the body completely and function within the body. I mean, consider all of the organs that are in your body or in any animal body. All of those things have to be working together, and that requires a lot of information to be in the DNA, right? So the question is, where does that information come from? And the theory of evolution does not have an answer for that, Topdawg.
It kind of does. We got the viruses, DNA duplication, cosmic rays can damage the DNA. We have DNA mistakes just from copying it day to day, or every time it's been copied, it can make a mistake, or it has a possibility.
Yeah, make a mistake. And what usually happens when those mistakes happen? Do new structures form within organisms? When have we ever shown that scientifically?
We can see the different animals of the same kind, type of animal with different features and stuff. Like all the birds, you see so many different variants of birds just in that. It's just such a vast amount of birds that just wouldn't make sense any other way.
Well, but those birds all have some properties that are the same, right? Like wings, feathers. There's like things that. So,
there's still dinosaurs. You know that.
Well, dinosaurs are just
a different type of
reptiles. I mean, so yeah, I would say probably it's really funny that we're saying birds are dinosaurs now. This is like absolutely absurd. But I mean, I don't know what the difference between a crocodile and a dinosaur would be. So, it seems like a crocodile would be much closer to being labeled as a dinosaur. But that should give you a clue that
they're before dinosaurs. I mean,
Well-
they're older than dinosaurs, but they're still the same, aren't they? You're going to say that they haven't changed from all this time, but they have changed. They just look the same to us. That's the thing. It's what we decide what is called something. It's not like a fundamental thing to the universe. It's our human understanding that what science is about. So, yeah, let's see. So you got to look at this stuff for yourself if you really want to know more about this stuff. That's let's even look at the definition of devolution. Let's see. A gradual process in which something changes into a different and unusual or more complex or better form.
Okay, now this
A
is
result
interesting.
of this process.
Now,
Well,
a different
it's
and
not.
usually more complex or better form. Now, that is the part that I'd like to challenge. Where do we see
Yeah.
something going to a more complex form? Topdawg, this is a story you've believed. And you've believed it because there's a lot of smart people who believe it. A lot of people with science degrees who believe it.
This is just the word evolution. I meant it's not the theory of evolution. I don't know if that first part is exactly what you think it is. It's not always better forms. I don't know why they wrote that. I don't know why I just read it.
Okay. Well, let's look at
maybe I should have looked up the theory of evolution. Didn't take time to actually read it before I said it. Let's see. Because that was a misunderstanding. It's not always better forms. It's just the form that fits in the in its environment. I guess it's better. That does kind of make sense. Better for its environment. It's not the whole story. It's a story, but it's based on evidence, if you know what that means. It's what theories are for, to help it better explain. You understand? Okay.
I understand, but I don't think evolution fits the evidence.
Oh yeah, biological evolution. Yeah, we need to look up.
Okay.
A scientific theory of the origin of species of plants and animals. Let's see. Scientific theory, a theory that explains scientific observations. Scientific theories must be falsifiable. Okay. The science that studies living organisms. Darwinism. I don't know what that's really. A theory of organic evolution claiming that the new species arise and are perpetuated by natural selection. Okay, just a lot of just what people call these things, I guess. A theory of organic evolution claiming that acquires characteristics are transmitted to offspring. Let's see, the next one. Theory of evolution holding that evolutionary changes in the fossil record came in fits and starts rather than in a steady process of slow change. Oh, that's something else. These are just the different versions that people call. Let's see. I don't think that was really helpful.
Okay.
Let's see. I'm bad at this, sorry. Biology. The genetic composition of the population during successive generations, often resulting in the development of new species. defined by us because they can't mate or they look so different that
Mm-hmm.
we consider them a new species. As species have multiple reasons or names or definitions, I think. So it's not. So it's you have to understand a lot of different things to know what a species is, I guess. Let's see. The mechanisms of evolution include natural selection, acting on the genetic variation among individuals, mutation, migration, and genetic drift, the historical development of a related group of organisms, phylogeny, I can't pronounce it, phylogeny. Oh, I'm sorry, bad at pronouncing things too.
Mm-hmm.
Okay. Yep. That one helps a little bit better. It's a mechanism. That's what the theory of evolution and a biological evolution is. So you got to look up the webpage, not just a theory, to understand a little bit maybe there too.
Well,
Look it up for yourself if you want to read all this.
I don't
Already did
believe
enough
everything
reading.
I read on the internet, Topdawg.
I know this one is helpful. It's not you need to believe it, you understand it. That's what the difference is. You don't believe things in science, you understand them. Because they're based on real life that we know of from somebody that have studied real life. So I hope you understand what that means. That's what I'm saying. Why this whole what topic was? What is science? It's our observation and experiments and stuff that we can understand the universe.
Right. But do you think
So-
scientists have ever been wrong about things?
Of course. Why
Okay.
wouldn't they be? They're human.
Okay. So,
But then we can find out better. By using science, we keep on getting more accurate. That's what the point is. We're getting it from other people's point of view and their experiments and stuff and observations. So we get more accurate at. That's what it's okay to be smart guy was saying.
yep.
The last part of you was saying that you don't just throw away the whole idea of how things happen, or the whole theory. I mean,
Sometimes we do need to throw out a whole idea. So,
but this has been proven, or not proven, but shown. We have seen the mechanisms and stuff. We don't, just like you were saying, don't need to throw or change a car or a flat tire. We just change that part that's wrong, so we get more
Yeah.
accurate.
okay.
Does that help you?
No, it doesn't. Because I don't think the mechanisms that we've observed have shown anywhere close to what we need for all organisms to evolve from a common ancestor. And whenever we
Well,
get
we have
involved,
DNA.
yes, we have DNA. I don't. What's
There's
the point you're
viruses
making
that
about DNA?
there are viruses that or endogenous viruses that get involved in our DNA that can't be replicated. And I mean, it's like astronomical because they insert the part of in their DNA that only can be like random. Like it's hard to explain. You have to look that up. I have actually form for retroviruses. See, endogenous retroviruses, ERVs. Yep, they have common ancestry. I got everything almost, or not everything. I mean, it's a lot. Obviously, you're not going to have everything. But if somebody wants to add their questions or want to fix anything that I have up here, then go ahead and log in, make an account or a membership, and start sending me questions or want to tell me that, or want to learn more about a certain subject or anything. And you could. This is all here for anybody to join.
Thank you, Topdawg.
Yep.
Well, I don't think our disagreement is about what is science. I think we agree on what science is, right?
And evolution is a part of science.
Evolution is an idea. It's a story.
Based on facts.
Well, let's define what evolution is. If we're talking about just simple changes within organisms, absolutely, it's a fact that organisms change. But do they change fundamentally? Do they add new organs and systems over long periods of time? And that's the part I'm challenging. I'm not challenging our scientific observations. I'm challenging what we have not observed. And we have not observed organisms adding new organs and fundamentally changing from one type to another. That is not something we've observed. So we can say evolution is
I'm sorry. Have you ever seen any like David Attenborough documentaries of life, like seeing all the like life being just life and stuff, just seeing all the different variations of life and how their environments and stuff shaped what they are today?
I probably have not.
There's a lot of them. David Attenborough. It's BBC channel, I think, on YouTube. Has a lot of little clips from his documentaries. And the animal hybrids, why are they hybrids? If they're supposed to be the same animal that could reproduce, if they have the same DNA and stuff, how would they reproduce? Why are they different enough, or not different enough to whatever how you say it? They're not different enough to not reproduce, but their offspring sometimes that become not able to reproduce themselves. But still, why are these different animals? If you ever look it up for yourself, because I don't want to keep on showing videos on the same stream.
Okay.
Those two were enough to help. It was just for the topic of what is science. And
well, yeah, maybe we can talk about one of those animal hybrids or something on a different stream, or we can narrow the topic and focus in on one of these things next time.
Yep. Because the common misconceptions about evolution is the second one that I posted to help clear up things. And then how evolution works is the next one, where it has multiple actual videos sometimes. Not always just one video. So you can get different perspectives and stuff. But even animal hybrids, I have a couple of those from different people showing different types of hybrids, yeah. And then you have somebody that helps us understand a question for what is intelligence, and there's no first human for another. That's got one video there, but there's plenty of videos from other people you can look up. Yeah, it's like I can always add more to these videos and stuff to help clarify or be more accurate. Or I can take away the videos just like that. But is this whole forum bad because or not part of science? Anything because it's confusing like that. You don't throw away the whole forum just because one thing's bad or it doesn't work or it doesn't isn't accurate to reality or whatever, something like that. We just throw out that one part
we don't have to throw away our observations, but I do think we should throw away the idea that we've descended from a common ancestor. I don't think that is...
Then you're saying that you don't have grandparents? That you never descended from your grandparents?
No, I'm not saying that.
That's a common ancestor from your other cousins and stuff.
I know, but it's not a common ancestor with bacteria, right? Like, I just because I know that I had grandparents doesn't mean that my great 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 grandparents millions of years back were, fundamentally different.
Well, we still have the DNA though. It's still in our DNA.
Well, I'm guessing,
We can-
Topdawg,
we
that
can-
you don't know enough about that subject, and neither do I, right? But
Let's learn together. Maybe we can help clarify for other people too.
I
Everybody can
think
learn
there's
together.
a huge difference between the DNA in other living forms than there is in human beings. And of course, with some mammals, we're going to have some structures and some of our DNA will be shared, but that still doesn't show that we descended from each other. Just means that we have a similarity.
But it's got also the viruses that can't be replicated that are injected in our DNA. So we could see the same virus, endogenous virus, in the same part of our DNA, showing that we were once had a common ancestor that had that virus, and we descended from it. So different life form or different creatures have different parts, different sections of their DNA that are viruses injected that can't be replicated. I mean, it's complex and stuff. And the universe is complex because it doesn't have an intelligence, too. Because that's another
Well,
thing.
now that's a big assumption, isn't it?
No, we can see it. We observe it.
We observe.
We notice
you
it.
said the universe is complex because we didn't have a designer.
Natural processes and stuff is the designer. It's kind of physics and stuff, chemistry, and I mean, those things are what we found out about the universe, and we're sectionalizing them too. So it's all one universe. It's just that we humans have to understand things in like sections because it's hard to understand any other way for a normal person to understand all the we don't have a theory of everything yet. That's one of the things in science we need or they're trying to look forward trying to they unify all the stuff in the universe to make it all one theory.
Now,
and it'd be the ultimate triumph of science.
But what about science would lead you to believe there's not a creator? I mean, let's put evolution aside. Even if you believe in evolution, I don't see how that has anything to do with a creator. How does science answer the question of whether or not there's a creator, or show that there isn't a creator, like you said?
It's not about that. It's about observing the universe and how it works and what it is about, or what it is from our own point of view. I mean, to be more accurate from all different points of view of people that contribute to science. So it's a human perspective. That's what science is. So we don't use science for morality either. So we get morality from the culture and the people we're around, and maybe how our brain works a little bit too. So it's on our environment is where morality comes from. So, and our brain. So
Okay.
it's complex. In that, I mean, simple things makes complexity too.
Simple. How do
That's
simple
because complexity
things make complexity?
I mean, a lot of simple things combined to become complex to us. I mean, complexity is like to the observer, but if you study enough, things become less complex. It's kind of like that. you learn something new and stuff. It starts out as complex, but then it gets easier, so it becomes simpler and easier to talk about maybe and explain it to others. So it's less complex for the person, but still complex for somebody else maybe. Complexity is not really a thing. It's a idea of from our own perspective.
Okay. Well, I disagree with that.
To I mean, everything is like quantum mechanics shows how simple, or it's not simple, but I mean, if you're looking at it individual like waves and stuff, and then it gets complex because the waves are so hard to predict. But
Mhm.
there is a prediction for to where electrons and stuff can be, but it's not 100%. That's why it's called a likelihood and stuff, or what's the other word?
Uncertainty.
Probability. There it is. There.
Mhm.
Yeah, on the uncertainty value and stuff. They have that pretty good now. So we're getting better and stuff. Really, we have learned or documented the basic structures of the universe.
Okay.
Let's see. I'm trying to think of the word it was called.
Where do you think we came from,
Like-
Topdawg?
Particles. That's what it is. We came. Which part? I mean, we have to know.
The universe.
We came from our parents. Oh, the universe
about the
itself. That's going
universe?
way back. Why you going? Need to go that far? But no one knows. They go other than from the point of the Big Bang theory explains. Helps us understand.
What does the Big Bang Theory
And then
help
theory
you
of
understand?
relativity helps.
Where did what caused the Big Bang?
We don't know that. That's outside of science.
Okay.
It's a lot of things that you have to. It's not just easy to just find out what science is. This is just a simple introduction to understanding how the process of science works. That's what the whole topic was about. Then we went into evolution.
Topdawg, I'm
It was
still
getting a little complicated.
but I'm still kind of, I mean, I'm a little bit offended, Topdawg, that you think I need
No?
to understand what science is. Like,
Why did you keep on saying that evolution isn't part of science then?
well, I don't think I said evolution is not part of science. What I said is the theory of evolution is not well supported. There's not evidence. There's actually quite a bit of evidence against the idea of organisms changing from one type to another. Now, I'm not saying that organisms, that we, like I said, you have to be careful about the definition of evolution. So is there evidence that organisms change? Absolutely. But changing from one type to another, building new structures and becoming fundamentally different creatures, I would say that is not scientifically observed and it's not scientifically supported.
That's why I was talking about animal hybrids earlier too. Why are they totally different looking, like donkeys and horses, but still can make a mule? And then zebras
Okay.
too. And then they can make these donkeys and whatever, all the other different names for different mix of those animals. They look totally
when you
different.
look at a donkey
I mean,
and
not
a
totally,
horse, there's some differences between them, right? But they're not altogether unsimilar. It would be a different story if you were taking a bird and a horse.
Yeah, because it's farther in the future that they spread their differences. But why is it just like the donkey and a horse haven't been different enough to make them have totally different where they can't make mate? Are animals like that, like normal cats and the house cats and tigers and lions and stuff can't make, but the tigers and lions themselves can make a liger, and the other one I can't remember the name. You have to look it up yourself in my forum where they show all the different types of animal hybrids, or you can look it up yourself on YouTube. You don't have to look at my forum. Just forum helps start you off with some idea or the concepts. That's what the whole point of it's just to help get involved, show you all the different versions of science or the fields of science. That's what it is. Trying to remember the particles and stuff. The name of the list of particles from earlier I was talking about. You hear me clicking on the type or on the keyboard.
Mm-hmm.
Let's see. For some reason I forgot.
Well, I think we're in agreement about what science is, right? Observations of the natural world, right? Like we do observations and experiments to discover things about the natural world.
There we go. I found it. The standard model of elementary particles. That's what I was talking about earlier. This is what we understand of the quantum level stuff. Particles are still waves. It's just that they're like it's packets stuff. It's confusing. You have to look it up for ourselves. Yep. They separate the particles as different types of particles too, like gluon or gauge bosons, and then you have leptons and quarks. Yep, this is all the basic standard model shows of what the universe is made of at the fundamental particle level. We recently found the Higgs boson in the last 10 years. Even though it was mathematical and stuff, but it took the Hadron Collider in the other side of the world to actually figure it out. They had the Higgs boson the understanding that it in their math, but they took them actual experiment and stuff, many experiments, to actually put it into the standard model. So we found a new particle. I mean, in the recent less than 10 years, so it's pretty amazing.
Cool.
Okay.
Is there anything else that you're wanting me to understand from this conversation?
I guess hope it's not too much at once. Getting all this information and stuff, so it makes it harder, and then you might not like it or something because I'm throwing it all at once on you,
That's fine.
Making you feel uncomfortable or something.
No, I don't feel uncomfortable.
Okay, that's good to hear. That means you're willing, right? You're willing to understand. You got to be careful of the people that don't understand and then claim to understand too. That's out there. So they're giving you false information because they don't actually care to look it up. They just hear a few things, or they cherry pick a quote or something that people said, and then they make up their own and stuff. So a lot of problems out there you have to actually look at the sources or the people that reference the sources.
Okay.
It's a long process of understanding the universe. You have to do it little by little, so you help better understand.
Yeah.
So I guess I do have one more video. It's a music video. It's also in my forum. It's a group or people called Melody Sheep on YouTube. I don't know if it's one or two people. They were a group, but they made music from scientific like documentaries or people talking about science and stuff, and put it into a certain subject. It's called Symphony of Science. Is their they do more than just science to talk, like Bob Ross or Robin Williams or let's see, Muhammad the boxer. They tributed to him and stuff. So Melody Sheep, let's look it up on YouTube if you want to see any good music that's from people talking about a certain subject or it's hard to explain. You just watch it for yourself. So here's lots of different subjects here, but the one I want, oh yeah, it's the poetry of reality. It's the let's see, you can't really see it, can you? Oh, oops. Oh yeah, science is like a poetry of reality. If you know what that means.
The
it helps
poetry of reality?
from people.
Mm-hmm.
Yeah, it helps explain. I mean, it's people explaining in a love letter to reality. Almost like I don't know if poetry is just for love, but it's just people writing about their findings of reality. It's like poetry. I don't know, something like that.
Lori
Okay,
Hayes
the
is
last
wanting
video,
to come in.
So should we allow more people to come in?
I'm fine with it.
Okay, I
That's
guess
up
I'll
to
post
you.
the link. StreamYard, here we are. We're gonna get new people now. But we're gonna play this one video before anything else.
Okay.
It's only 3 minutes. Hopefully that's not too long for music.
Science is the best tool ever devised for understanding how the world works.
Science is a vehicle for knowledge. We are always at the brink of the node. Science is a collaborative enterprise spanning the generations. We remember those who prepared the way, seeing through them also.
If you're scientifically literate, the world looks very different to you, and that understanding empowers you.
There's real poetry in the real world. Science is the poetry of reality.
We can do science, and with it, we can improve our lives.
There's real poetry in the real world. Science is the poetry of reality.
The story of humans is a story of ideas that shine light into dark corners.
Scientists love mysteries. They love not knowing.
I don't feel frightened by not knowing things. I think it's much more interesting.
There's a larger universal reality of which we are all a part.
The further we probe into the universe, the more remarkable are the discoveries we make.
The quest for the truth in and of itself is a story that's filled with insights.
There's real poetry in the real world. Science is the poetry of reality.
We can do science, and with it, we can improve our lives.
There's real poetry in the real world. Science is the poetry of reality.
The story of humans is a story of ideas that shine light into dark corners.
From our lonely point in the cosmos, we have, through the power of thought, been able to peer back to a brief moment after the beginning of the
I
universe.
think that science changes the way your mind works to think a little more deeply about things.
Science replaces private prejudice with publicly verifiable evidence. There's real poetry in the real world. Science is the poetry of reality.
We can do science, and with it, we can improve our lives.
Hello, how are you guys?
Hey.
Good. How are you, David?
Okay.
Good, thank you. I'm sorry, I knew this was happening, but I was busy this morning, so I've only been here for 5 minutes, maybe 10, not even 10 minutes, I think. You guys have been on for a while. You been talking about anything
Just
good?
an hour and a half.
Yeah,
Just
I see
what is
that.
science and
Yeah.
a few other subjects.
So I'm very glad to see you here, Rebecca. Thanks for coming. Anyway,
Sure, my pleasure, David.
I'm glad. We watched, of course. We watched a lot of the other videos. I saw you had a couple of interviews with Sal and talking about Speech Channel. As you know, I'm on Speech Channel a lot, so.
Okay, cool.
I'm glad that that you're willing to come back and have chats. Some of the stuff we talked about a little bit was that that maybe you felt like you were attacked a little bit, or did you feel that way, or no?
Oh,
I mean, maybe in
well,
chat.
when? And not on, when I went on Mike's channel, there was 2 times when I was with Demeter and Mike, I
Yep.
did not feel attacked. But of course, there was one time when I jumped on and I knew it was going to be that way. There were like,
Yeah.
8 or 9
I mean-
atheists on there. And so that day I was a little bit caught off guard because they were asking me a lot of,
Yeah.
scientific questions that I
Yep.
couldn't answer. But that's okay. I mean, I'm not a scientist, so I don't
Yeah.
expect
Yep.
myself to know all these things.
Yep.
But
Well, I just wanted to kind of touch base on that a little bit, and I can understand you feeling that way, but I think that just so you know, I mean, everybody, at least the people that frequent the channel that actually go on, not so much the side chat. I don't know if you followed it at all or not, but we tried to control the side chat a little bit. If people were insulting or whatever, that's not what the channel is about. That's not what 90% of the people that frequent the channel are about. We're not about going after anybody, like that. So
yeah,
I just wanted to make sure that that's very clear. Maybe, people, like you said, you jump into a room full of atheists, and that's true on the other end too, right? You watch, a Christian channel, and if an atheist jumps in there, everybody wants to ask the question. They kind of want to have the little debates and everything, and
yeah.
So hopefully, I just wanted to. I'm sure I can speak for most of the people that frequent Speed's channel that we're not, they're not like that. They're not trying to attack anybody. Just trying to have conversations and stuff. Yeah.
I haven't been offended by anything that's happened on Speed's channel at all. I'm actually quite used to people being rude in the side chat. It doesn't bother me. So it's no problem.
Yeah, it's typical. People tend to be that way. Everybody tends to be that way almost a little bit, one way or another. So, yeah.
Well, for me, I'd rather be an honest, rational human being than just claim atheism.
So what have you guys?
Atheism is not not really anything, because you could be anything but a theist. That's all atheism is. So you could be anything you want to be.
Yeah, absolutely.
Just not theist. That's all.
So what have you guys
we're
been
just all
talking
individuals.
about? I'll probably try to go back and listen to it. What you guys were talking about earlier. But anything interesting or?
I can sum it up in a few sentences.
Sure.
Topdawg wanted to bring me on to explain to me what science is.
Fine. Yep.
Okay.
Yep.
And, but I gave him a definition at the beginning that I think agrees with his definition, right?
Yep.
That
Yep.
science is observation, experiments, and things that we do to discover truth about the natural world. So I don't think we have a different definition of science, but Topdawg believes that because I don't accept evolution, and specifically that we all descended from a common ancestor, right? Because I do accept evolution as change within organisms, but because I don't accept the idea that we all evolved from a common ancestor, he believes that I don't understand science.
Yeah, it is very confusing for a lot of atheists because, I mean, each theist, of course, everybody has their own different views and different ideas on it, and it is kind of confusing with theists because of the fact that you don't know how much they accept. Like you just said, the certain depths of evolution, and which parts you accept, which parts you disagree with. And, because there's a lot to it, right? I mean, there's plenty to it. And then other scientific areas too. Now, you would be a young Earth, correct? Or would you be a young Earth? Yeah. So, I mean, other fields too. But, go ahead, Topdawg. You want to say something? Go ahead.
It's not just theists. It's just people. It could be anybody. Everybody's an individual. I don't know why we have to bring up just theism. I mean, it's just that the people that have a hard time understanding science because it contradicts what they believe in the Bible or something, makes them go against science. So, of understanding, I mean, of the natural world. Is that what you're referring to when you say theist, I guess? But it's not just theism.
So, Rebecca, I just want to ask you, so how much of other fields have you, had any interest in? I mean, have you looked into any other fields? I mean, obviously, when it comes to, being a young Earth, right? I mean, to put it bluntly, you kind of disagree with a lot of mainstream science, right? Would that be fair to say?
I'll just kind of lay it out for you. I believe that my rejection of evolution as descent from a common ancestor, I believe that is based in science, right? Like I think that I have good scientific reasons to reject that idea. Now, when it comes to young Earth, I will say that my beliefs about young Earth, I hold them much more tentatively. And so I recognize that there are some scientific observations that seem to contradict the young Earth. Okay. And I also think there are some scientific observations that support young Earth. So with young Earth and regard to the science, our scientific observation and how that fits in with young Earth, I would say I have evidence on both sides that I'm weighing, right? And so and I would say there's some good evidences against young Earth and some good evidence for young Earth. But the thing that kind of tips me toward young Earth, because I'm not an expert in science, right? I accept science as a valid way of discovering truth about the world. And I also think the Bible is a valid way of understanding truth about the world. And so the reason I'm kind of tipped toward young Earth is because I think that the way that the Bible presents creation, the most straightforward reading tends to lend to the young Earth idea, right? I'm not saying there's not, if the science was overwhelming for old Earth, I think that could also easily fit within the biblical narrative. So I would have no problem with old Earth, but I think evolution is a little bit harder to fit into the biblical narrative. And there are Christians who do it though. So, I mean, I think it's possible. So, I wouldn't say that anyway, I'm explaining where I'm coming from. I have the Bible as a source of truth and science as a source of truth. So like I'm kind of like
which one is more important to you? I would say the Bible, correct?
Well,
which is more important?
No, I would say that what's important is discovering truth, right? And so like
and how do you get truth?
Well, I just said, I think the Bible is a source of truth. I think scientific observation is a source of truth. I think there's other sources of truth also. We have our personal experience as a source of truth. There are lots of ways to experience truth about the world. But if you're asking me to make a choice about like, okay, which one am I going to go with? Well, I don't like to think in those terms, because if there's something scientific that absolutely contradicts my ideas about the Bible, well, then I'm going to have to, I need a way to reconcile those two things.
Yeah.
I'm not going to just say, oh, boo on science, I'll go with the Bible. Do you see what I'm saying?
How do you do that? How do you reconcile that?
That's what I said.
No, you just said you need a way to
truth.
You said you need a way to reconcile that. How would you go about that? Could you
Well, I would look into whatever subject until I
until you came to a satisfactory idea. Okay. Yeah.
Yes.
So that's what I was saying. I needed to clarify first that what is truth to you?
That's a real
truth is just a definition of it's reality, right?
You're gonna go down a deep rabbit hole with that one, Topdawg.
For me, it's statements about reality.
Okay.
That can be confirmed or verified.
Yeah.
Because why would it be true if it's not confirmed or verified?
Yeah.
You can just make up anything you want if it's not confirmed. Yeah.
Truth is relative. Some people would say that that's a deep subject, deep philosophical subject that you could really go a lot of ways, right? There's a lot of different views on that. There's a lot of that's a tough one to really go down. So for me, let me say, as far as like science is concerned, to me, you may have a totally different view of it, but for me, I'm confident with the scientific community and the studies that they do, and and the conclusions that they come to. I don't have a problem with it. Like, I don't go searching. If science comes to the conclusion that the Earth is 4.5 billion years old, and that's what the consensus. I know a lot of theists hate that word. Oh, you shouldn't just rely on consensus, but I'm comfortable with that with myself.
Okay.
With they that's the conclusion science has come to, and especially today. Like, if you went back 100 years from now, you go back 100 years, we didn't have the technology that we have today. But when you're living in the 21st century here, the technologies, the chances of them
be more accurate,
science being way off, are pretty slim. Would you agree with something like that? Like,
no, I don't agree. And the reason now in certain areas of science, I would agree. But when it comes to the theory of evolution, I disagree strongly. And it's because I think it's much more like the theory of evolution gets its strength from two sources, and it's not scientific evidence. It gets its strength from a commitment to naturalism, a commitment to the idea that we must have a natural explanation for everything that we see. And we need evolution to be true, because there simply isn't another viable natural explanation.
You're conflating abiogenesis with evolution, right? Wouldn't you say that?
No. I'm
because
saying
you're saying that evolution has to do with all naturalism, which you're kind of conflating abiogenesis with evolution, I think, there. Because I don't know.
It comes from the same philosophical commitment, and that is that we need an explanation that doesn't include anything supernatural.
Okay, so all right, so let's go with the two differences between you're talking about abiogenesis, which is, how life got itself established, right, on the earth, right? So let's say, okay, as you know, science, we don't have answers for that. We can't, we have tentative pathways, but that's the best we can do with that. But when you jump into evolution, I mean, we have a lot of answers from there on. Now, do you believe that there's any type of supernatural intervention in that process after the fact that once we have single cells? And I mean, do you think God, so that's why I'm saying.
Yeah, David, I think you do need a lot of miracles even after abiogenesis. Okay. I don't think that we actually, what's that?
Where would you put those miracles?
First of all, I don't believe that I don't believe in any part of that process. I believe God created, okay? But that I realize that's not a scientific that's my personal belief, right? But what I'm saying is I don't think that once the process, okay, if I give you abiogenesis, right? But I still think that we have not explained scientifically the mechanisms that could have provided for that first organism to develop into everything we see today.
Right. See, that's what I'm saying is you're conflating abiogenesis with evolution, and you're not separating the two. And
I'm giving you it. I'm giving you abiogenesis. I'm saying I'm not even considering that. I'm giving you the first cell. Okay. And I'm saying from that first cell to get to where we are today, I don't think we have a scientific explanation for how that could have happened. But I think so I was saying, I think the two reasons that the theory of evolution is strong, why it's widely believed is because there's a philosophical commitment to naturalism. We must find a natural way to explain. And the indoctrination that has occurred for the last 100 years, even all of us who have been Western educated have been given these ideas about evolution from a very young age. So I think those are the two drivers of this theory, but I don't think that we actually have the scientific evidence to back up that these types of changing an organism fundamentally, where an organism grows, a new organ, a new structure. I don't think we have any good scientific support for that idea.
Yeah. I mean, I would have to disagree. I think there is a lot there. And I think, of course, there's a lot of things that we can't explain completely, right? You certainly don't have all the answers, right? I can't sit there and point to one specific thing and said, okay, that made a lung, that made this, but when it comes to evolution, I think there's mountains and mountains of evidence to prove it. I mean, truly, if you talk to anybody, the field itself, in the entire scientific community, they would all agree that you hate to say it's a fact, but it's because there's so much overwhelming evidence there that it's a done deal. Like, it's just, you can't deny it. But I know somebody like you, I mean, you can, obviously you are, and there are people that can, but yeah, I don't know. I don't know if I could put it any better than that, but
yeah, David, of course, I don't have the scientific expertise, but I will say that, there is a minority view. There are very good scientists who have rejected the, idea of evolution happening, like the descent from a
But
common
yeah,
ancestor.
I wouldn't
So-
disagree with that. But those
Yeah.
people would be on the fringe. Would you?
Well,
would
you know,
you wouldn't agree with that? I mean,
for every idea that has been overturned, it started with somebody being on the fringe, right?
yeah,
And
that
so
could be.
I mean, I'm fine
Could
with
be.
it being called the minority view or even the fringe
Yeah.
view. The question is it the correct view? And I think when you actually do examine the evidence and when people actually listen to the minority view, you'll see the minority view has some pretty strong evidence.
Yep.
But are they the minority, the actual scientists? They're actually doing the work, or are they
Yes.
just making claims?
Well, they're demonstrating that, you know, what is being claimed by the majority view is not good science. So
Then it should be overturned if it accurately describes reality.
And yeah,
That's,
So how
anybody
long-
can do it. Anybody can make or if discover their own science or discover their own way of that certain topic, and then overturn the people because it's more accurate.
So what
Overturn
about
the past,
some of the other
versions
fields?
or whatever.
Do you? I mean, you said you're not really, totally committed to young Earth. Do I have that right? Like, I mean,
Yeah,
like
well, like
the
I
other
s-
fields, geology and and what about physics? You look out at the universe and physics and cosmology and all those things will say that the universe is 13 billion years old, 13.7 or whatever it is. Do you have any? You don't seem to have any conflict with that, or like?
Well, yeah, I mean, I would say, look, we look out and we see stars that are a certain distance. How did the light get to us? That I would say that's an evidence, against young Earth. But then also for for this whole cosmological model to hold together, there's also unexplained things that cause a big problem. So for example, why do spiral galaxies still exist? That shouldn't happen within the model, but this does happen. So they've constructed this thing about dark matter, which has never been observed. So we need a lot of things.
There's evidence,
but we have we're looking at black holes and things like that, right? But what I mean is we have to assume the existence of that, 70% of the matter of the universe is unobserved. Now, I have a problem with that, right? Because so your model is dependent on the existence of something we don't observe. So
gravity
I'm
does
just
that
saying,
too.
there's enough questions in cosmology, and there's enough,
I mean, because there's
overturning of this and that.
Well, because there's some unknowns, you're going to just throw it all out with the.
No,
I mean,
like
you're
I
kind
said,
of
I'm
throwing
not
it all.
throwing it out.
Well,
No,
I
I'm
mean,
not throwing it out. I'm saying they could be right, but I'm not ready to base my entire worldview on a model that has that many problems. Do you see what I'm saying? It's not that I throw it out. I don't throw it out. I just hold it tentatively.
Yep.
And especially with cosmology, because 1 week, you've got one model, there's a lot of changes that happen with these models. So I'm not ready to base my worldview on something that uncertain. So I'm not rejecting what's proposed. I'm just saying, I can't base my worldview completely on that.
Yeah.
Mm-hmm. And the other unknown is the expansion, the dark energy. We don't know what that is either. But we understand that it's not expanding just in our area; it's expanding everywhere. So everywhere it looks like expanding. So it looks like the center of the universe everywhere, anywhere in the universe. So it's not just our point of view. People don't understand that. I heard on Maddox's channel or something like that one of the people on there where they were talking about it. They think that because the universe is expanding here, they think that it's the center of the universe or something. So that's one of the problems with educating the people that don't want to understand the real life science of how we got it, our information and stuff. They don't want to hear that other part. They just want to like cherry pick it, like only what they want to believe. So it's hard to get through those people that strongly cherry pick and don't want to hear the actual rest of the science.
So for me, Rebecca, the way you describe that is, you know, you don't want to base your worldview on on models that aren't completely understood.
Like
I guess
70%.
No, that are subject to change and have like.
But everything is subject to change, right? Everything.
Well,
right?
I mean, if
would you agree with that?
Falsifiableness.
Yeah, I mean everything is so. But for me, so let me explain it. For me, you know, you're saying you wouldn't base your worldview on something that's has problems, right? But for me, like, in order for you to maintain your worldview, you have to make a lot of sacrifices, right? You have to disagree with a lot of studies that you would have to say that are completely wrong. Would you disagree with that? I mean, like, you know, science is saying the Earth is 4.5 billion years old. The universe is 13.7. You know, dinosaurs walked 60 million years ago. There's so many things that you have to just disagree with in order to maintain your worldview. Well, hold on, Topdawg, hold on.
I'm sorry.
Right? Would you agree? Would you agree with that? Or?
Well, okay, I haven't spent a lot of time reading physics papers and things about cosmology. Okay, that's just and if I did spend time reading them, I probably wouldn't understand them. So
yeah, but I said a lot of things.
I know, but
right?
And that's why I'm saying I don't take a strong position when it comes to that stuff. Okay, the strong position that I take is with regard to evolution. And so I have not yet been presented. I haven't yet been presented with a single paper that would cause my worldview any tension. Okay.
Right.
So,
but do you understand what I said, though? Right? I'm saying that to hold your worldview, you have to make a lot of sacrifices. That's what I meant. I'm not pinning anything down specifically. I'm saying the whole picture, the whole entire picture of your worldview disagrees, and you have to make a lot of sacrifices. Do you understand what I'm saying there? Like, I'm talking about everything. I'm not just saying, you know, evolution. I'm not just saying cosmology. I'm not just saying, I'm saying the whole picture. You have to make a lot of sacrifices.
I know, David. And this is what I find. Okay, look.
Okay, I'm listening.
When I try to talk about evolution, people want to move the conversation to young Earth creationism because, you know, it involves so many more assumptions. And like you said, you know, there's a lot more fields that are involved with that, right? And so, you know, I told you I hold young Earth creationism tentatively.
Yeah.
Okay.
Yeah.
And
okay.
I've not gone and done, you know, research or great deal of study into these areas. So I prefer to stay off of that ground because I'm fully admitting to you that I can see evidence on both sides. Yeah. So, but the position that I do take a strong position against, and I do believe that I have good reasons,
right?
Is evolution. So I'd rather stay on that because that I think is the big issue with regard to what people think is, you know, a scientific explanation. And I'm saying I have not seen, right, a single paper that conflicts or causes tension within my worldview.
I think there lies your problem right there, if you don't mind me saying, is that you're looking for a single paper, and you'll never find that, right?
Well, I'm looking
Because
for an
there's
answer.
so much. Yeah, but I mean, the way you describe that is you're looking for that one thing. You're looking for that one thing that's going to overturn it and change your complete view, which is you have to look at the big picture of it, right? Evolution is a huge subject. It's not just, and you'll never find that. If you're looking for a scientific paper that's going to describe evolution, and answer all the questions that you have, you'll never find that. So that's just
it doesn't have to be a single paper. It doesn't have to be a single
that's
paper.
That's what you were saying.
It could be a single answer. Okay.
Yeah.
And I think evolution should give an answer for how new structures and new. Well, I don't think it does. Mutation tells me how we break the organism, or how we can make a small change to information that already exists.
It's the ones that survive in their environment.
About genetic drift, all of these things that are described as mechanisms of evolution tell me how we make changes to the information that already exists within organisms. It doesn't tell me where the information came from in the first place. And that is what evolution is lacking. And I'll let you guys have the final word, but I have to go get ready for work in a few minutes.
Absolutely.
So you guys can have the final word, and then we can close it up.
No, I enjoy it. You can have the final word, but thank you so much for the short conversation anyway. And hopefully you'll be back at speeds and all that. So yeah, I'm not going to add anything else, but thank you so much.
Okay.
Trying to understand you. That's all. And hopefully I kind of put my side out to hopefully you understand where I come from and try to understand where you come from too.
Well, I'd like to understand more, David. You know, I think you were mostly asking me questions, so I don't know where you're coming from.
Oh, okay. Well, we can.
But you seem like a fairly reasonable person, so maybe we can have another conversation.
Sure. Oh, yeah. I'm at Speeds all the time, and hopefully you can jump in and, Speed, he's real good at, he'll, make the room smaller. So it's not, you know what I mean? You could just jump in with, a lot of times if you want to jump in and just talk with us at all, Speed will, start off his weather report, and he's usually just has myself, Scott, and him, maybe Topdawg. It's usually small. He tries to talk about something scientific or whatever for the first hour, and he'll keep the room small. And if you want to come in and chat a little bit, that would be a good time. Like if you ever want to chat with us or Speed or the group, that's the best time to jump in, because it's a small room, and he will keep it that way for you. That way it's more comfortable for you. You're not getting bombarded like you said. You jumped in and you were getting bombarded. So just a thought.
No, but that's fine. I was fine with it. Wasn't, it's fine. Okay. Thanks,
all right,
guys.
Dear.
Appreciate it.
Thank you.
Okay. Have a good day.
My last thing. Stay curious. And people can live their lives without caring about science. It's just a spread of misinformation and disinformation that we try to fight against. So that's what the point.
Thank you, Rebecca.
Yep.
Thank you.
Bye-bye.
Thank you, guys. Yep. Stay curious.
Okay.
All right. I think he left.
Yeah, he just dropped out. I guess I thought I would.
Okay, I'll just drop out too then.
Yeah.
Okay. Bye.
Bye, dear. Have a good day.
Oops, sorry. Hit the wrong button.